I'm waiting for my presentation to be displayed. Okay, our next topic is types of lightning schemes. We have already seen basic principles of light control in the previous class. Okay, so today we will see what are all the different types of lightning schemes. It's an interesting topic. Okay, so if a lightning scheme is a good lightning scheme, it should be attractive. Okay, it should have commanding presence of objects, and it should enhance the architectural style of the interior of a building. Okay, so good lighting should always be attractive. It should have commanding presence of objects. It should enhance the architectural style of the interior of a building. Just for example, I have downloaded some images. I'm showing you. You can clearly see each and every object in this room for based on the given lightning. Okay, based on the given lightning in this room. Okay, so you can see some lamps that are placed just above the table, this table. Okay, so the main purpose of these lamps is to provide proper illumination on this table. You can see a smaller lamp here which is nearby to this wall. So the main purpose is to lighten this wall. So here you can see one more small lamp. The main purpose is to enhance the beauty of this whatever image or painting, whatever it is there here. Okay, so you can see here and there at many places you can see table lamps are also there besides to these sofas. Okay, so it should be commanding in nature. It should be attractive. Okay, so here also you can see one more image. Okay, so proper illumination is there in this. Okay, and it is making everything very interesting to look after. Okay, these rooms are looking very interesting. Okay, just an example I'm showing you this. Okay, so let us go into the subject. Okay, so depending on the requirements, in just now I have shown you three images. So all these three images were belonging to the three different houses maybe, and depending on the requirement, people will fix the different types of lamps in their houses at different locations. Okay, it is not necessary that the lamp should be always installed on the ceiling. Okay, okay, it is not necessary. If some people are more artistic in nature, they would like to decorate their houses and they want to enhance the beauty of their house by the lighting decoration. So based on the requirement, they will use different types of lamps. Okay, so it is not always the purpose of lightning is not always for reading only, reading or writing, or it is not always that lighting should be always on the ceiling, so that the light should fall on only on the lower surface of the room. It's not the only purpose. Okay, so based on the requirement, the lighting can be categorized or classified into the following, such as direct lighting, semi-direct lighting, indirect lighting, semi-indirect lighting, or general lighting. Okay, so let us discuss one by one. Okay. Okay. So first one is direct lighting. So if a lighting is a direct lighting, okay, so the most of the light from the direct lighting will fall on the surface. Okay, so this is an example of direct lighting. You can see here a lamp is fixed above the work plane. This is a work plane table. So it is fixed above a work plane. 90 to 100% of the light is falling on the surface, not only on this work plane, surrounding surface also. Okay, So here you can see some V shape. These are known as reflectors. So reflectors are provided surrounding the lamp in order to make the surface more illuminated. Okay, so in order to make the lamp more effective, okay, in order to achieve more efficiency of the lamp, usually reflectors are provided. Okay, so whenever I want 90% to 90% to 100% illumination on the surface of my floor, I will go for direct lighting. Okay, for you people slides will change, for me it will not change. Okay, so this is direct lighting. Okay, so it is the most widely used lighting. Okay, so direct lighting is most widely used lighting. Even in our colleges, the lighting that we use is the direct lighting. Okay, but there is a drawback for this lighting. The drawback is that it has been found that this type of direct lighting suffers with harsh shadows and glares. Okay, so that's the only drawback. Okay, so you can see an image here showing dark shadows. Okay, so in this image you can see a room here. This is a direct lamp. Okay, direct lighting lamp that is placed here. Okay, so what type of lamp we have already discussed, based on the syllabus we have discussed some few lamps in the subject. Okay, so whatever may be the type of lamp here, irrespective of that, based on its position, okay, it is fixed to the ceiling, so you can see dark shadows here. Okay, so direct lighting always causes dark shadows. Okay, and in order to make it more effective, we use reflectors. So you can see a dome shaped structure here. This is the reflector, this is also a reflector, and you can see with this is also a reflector. Okay, so usually these reflectors are made up of polycarbonate, prismatic, glass prismatic, or opal glass, or gray spun aluminum. Okay, okay. So in your last class, I think I have discussed about the opal glass and the frosted glass. Okay, so the only drawback is it causes shadows and glare, and you can make it more effective by using reflectors. Okay, direct lighting can be made more effective by using reflectors. Okay, so while designing these direct lightning lamps, okay, it is means since it causes glare to the eyes, okay, it can be eliminated by using proper reflectors. Okay, not the one of the purpose means, of course, the efficiency can be improved by using reflectors. Even the glare to the eye can also be eliminated while designing these lamps. Okay, of course, by connecting reflectors, they will absorb, I have already discussed about the reflectors, they will absorb some of the light energy, and they will scatter the light in all directions. Okay, so generally direct lightings are used for industrial and general outdoor lighting. Okay, so you can see and some office here. Okay, you can see direct lightning lamps here. Okay, so this is the direct lighting. So what is direct lighting is? Direct lighting is that in which the lamps are fixed to the ceilings. Okay, and they the surface, 90% to 100% of the surface is illuminated. In order to improve the efficiency, in order to make the surface more to get 90% to 100% illumination on the surface, these lamps are provided with reflectors. So you can see it is the reflector inside lamp is provided. Okay, and one of the drawback is that it causes glare and dark shadows. That is about the direct lighting. Next one is semi-direct lighting. Okay, semi-direct lighting. In semi-direct lighting, 60% to 90% of the lighting means luminous flux from the lamp. Okay, so lighting falls on the surface, and remaining 40% to 10% will fall on the walls, or it is directed towards the ceiling. Okay, so generally, in general, what people know is that lights are fixed in such a way that the whole light should fall on the surface. It is not necessary that the whole light should fall on the surface. It can even be directed in the direction in which we want. Okay, so in this image, if you observe 60% to 90% is directed downward, the remaining is directed upward, means 40 to 10%. So this is the best example. I think you can, if you see the second image, 60% of the lighting is directed downward, and 40% to 10% is directed upward. So there is one more example here. In this image you can see, based on this luminous flux, okay, luminous intensity I can say. So you can see the luminous intensity on the bottom side is more when compared to luminous intensity on the top of this lamp. Okay, you can see two lamps are fixed besides to this mirror. Okay, so in order to get more illumination on the lower side, on the lower surface, okay, semi-direct lamping is used. Even whoever has installed these lamps in their house, they even wanted to illuminate the walls. Okay, but they wanted less illumination on the walls. That's why they have used semi-direct lamps. So in direct lamps, 90 to 100% illumination is means luminous flux is focusing on the surface, bottom surface. Whereas in semi-direct lamp, 60 to 90% is focusing on the surface, and the remaining is reflected upward. Okay, or focused upward. Okay, so generally, semi-direct lamps are used in the rooms which have high ceiling. Okay, but and one advantage of this semi-direct lamp is that glare can be avoided. Okay, and if proper diffusing globes are used, you know what is meant by diffusing globes. We have already discussed about diffusing glass. Okay, it scatters light in all directions. Okay, so this scheme will improve not only the brightness but also the efficiency of the lamp. Okay, so you can see one more image which shows a semi-direct lamp. This is an example of a semi-direct lamp. But simply by looking at this lamp, it won't seem that it's the semi-direct lamp. But if you see this image is the best example. The third image in this slide, the third image is the best example to show the semi-direct lamp. Okay, I hope you are able to follow. Next one is indirect lamp. Okay, so actually we should I should use the word indirect lighting. Okay, so in the case of indirect lighting, in this the lamps will be throwing out the light towards the ceiling. Okay, most of the light, luminous flux lines are focused towards the ceiling. Means 90% of the illumination is provided to the ceiling, and 10% of the illumination is provided to the surface. Okay, so whenever we want to decorate the ceiling, whenever we want to highlight the ceiling, in such cases, we will use these indirect lighting lamps. Okay, so here ceiling acts as the lighting source. Okay, so whenever you are illuminating the ceiling, just for example, if you see in this image, okay, it doesn't mean that the surface of in that room will be dark. Okay, so whatever light is falling on the ceiling, 90 to 100%, even 100% can be reflected to the ceiling. The light rays, they will strike the surface. Okay, so if you see, the surface is a diffused surface, isn't it? The ceiling is not a specular surface, it is a diffused surface. So the light rays will strike this diffused surface. From there it will the light ray will be reflected back. Okay, to the nearby some other surface with some reflection angle. From there it will be again reflected back. Okay, and it will fall on the surface. So it doesn't mean that if I use only the indirect lighting, only the what is it, ceiling will be illuminated. Okay, so the whole room will be illuminated because of indirect lighting also. But the thing is, the ceiling is more illuminated when compared to the surface of the room. That's all. Okay, because of this type of lighting, definitely you will get a shadowless illumination. No shadows will be there in the room. Okay. So actually, in practice, in general, people, those who mostly use drawing offices, mean those who want to draw, they prefer shadowless illumination. Okay, so indirect lighting is preferable for drawing offices. Okay, and the offices which have work more means which use large machines. Okay. Okay, so whenever large machines are there in the industrial places, like, okay, so in such places, when people don't want shadows, they will prefer the indirect lighting. So this is one more example of indirect lighting. Okay, so you can see how the light rays are traveling towards the work plane due to indirect lighting. So the lamp is focused upward. Okay, these are the reflectors below this lamp. The light is traveling towards the ceiling. From there, it is falling on the nearby wall, and then from there, it is falling on the work plane. Okay, so whenever we want shadowless lighting, we'll prefer the indirect lighting. So there is one more image here. Okay, so in this also, this is how the indirect lighting provided rooms will look like. Okay, so if I want more illumination, I must fix more number of lamps. Okay, so in order to get more illumination, more number of lamps must be fixed in a room. Okay, that's all. So one more example of indirect light. Indirect in this, actually you can see both indirect and direct lighting. So you can see with reflectors, direct lighting lamp is there, and this is an indirect lighting lamp. Okay, which has of course, its reflectors are facing the ceiling. The reflectors of direct lighting lamps are facing downwards towards the surface. So this is one more, see on the side of the wall, you have indirect lighting lamps which are fixed. Okay, so the light will fall on the wall and it will be reflected back. Okay, so this is about indirect lighting. So in indirect lighting, 90 to 100% of the lighting will be focusing towards the ceiling. Okay, so next is semi-indirect lighting. So in semi-indirect lighting, 60% to 90% of the lighting will be focusing towards the ceiling, and remaining 40% to 10% will be focusing towards the surface. Okay, so in this, by using this semi indirect lighting, glare can be completely eliminated. Okay, so usually this sort of lighting is preferable in indoor lighting decoration purposes. So you can see 60% to 90% is facing the ceiling, and 40 to 10% is facing the surface. So this is best example. By looking at this image itself, you can easily tell. So here the lighting is focusing towards the ceiling 90%, and a very small portion is falling, or the luminous flux rays, a small portion of the luminous flux rays are traveling towards the surface. Okay, so that's it. So one more semi-indirect lighting. So this is an office. Okay, this is an office. In this you see almost 60 to 90% of the lighting is facing the ceiling, and remaining 40 to 10% is falling, okay, on the work plane. And you can see there are no shadows. Light is uniformly distributed throughout the room. Okay, so this is about semi-indirect. Next is general lighting scheme. General lighting scheme, mama. Okay, so in case of general lighting scheme, general lighting scheme is the combination of direct lighting as well as the indirect lighting. Okay, so in the general lighting, we will use diffusing glasses. Okay, so you know what is a diffusing glass. So we will use diffusing glasses which are in which the lamps are placed. Okay, so that proper illumination is provided in the room. Means the light rays, luminous flux rays travel in equally in all directions within the room. Okay, not only to the ceiling, towards the walls, as well as towards the surface. Okay, whenever I want equal illumination in all directions, I will prefer general lighting scheme. Okay, so the mounting height of such general lighting lamps should be such that it should be always above the eye level to avoid the glare. Okay, so usually the brightness relationship throughout the room are will be very good whenever we use general lighting scheme. Okay, so the upward light, which whatever light rays are, since the light rays distributed uniformly, the whatever light rays, luminous flux lines are traveling towards the ceiling, they will soften the shadows of the direct light component. Okay, so some of the light rays are focusing towards the surface. Okay, so this is an example. If we see these lamps, this is where is it? uh, if you see these lamps, these lamps are distributing light uniformly in all directions. So some of the light rays are directly falling on the surface. Okay, some of the light rays are directly falling on the surface means that it is operating as a direct lightning scheme. Okay, so direct lightning lamp, we can, in my words, okay, according to me. So definitely dark shadows will be formed here and there. Okay, so whatever light rays are traveling towards the ceiling, they will be reflected back towards the surface, and they will soften the shadows that are induced on the surface because of direct lightning flux lines traveling from the same lamp. Okay, so this is an image. So when the light is completely enclosed or concealed with the help of globe ceiling panel, the light is diffused since passed through the glass or plastic. Of course, okay. So here you can't see the lamp, isn't it? You can't see the lamp, you can see the globe. Okay, so what is a diffused glass? You already know this globe is nothing but a diffused glass. So diffused glass will scatter the light rays when they enter into that glass, that you already know. So whatever comes out from this diffused glass, it will be distributed evenly into the room. Okay, so this is one more example of general lighting. So actually, for a student, you people should draw this. So if you see in this image, I have combined all the lightings here. So if you see this first lamp, 100% of the luminous flux is traveling from this lamp towards the surface. Okay, so that is our direct lighting. Okay, so if you see this lamp, the third one. Okay, the first and second are same. So if you see the third one, okay, 60% of the light is traveling, 60% of the light is traveling towards the surface, and remaining 40% is traveling upward. So so only 40% is illuminated on the upper side only. um, what is it, 60% is illuminated on the lower side. Okay, so that is semi direct. Okay, next if you see this lamp, okay, 50% is illuminated towards the ceiling, 50% is illuminated towards the surface, means it is providing 50% illumination on the surface, and it is providing 50% illumination towards the ceiling. Okay, so it is the general lighting scheme. Okay, this lamp is this lamp comes under general lighting scheme. So it diffuses. Okay, means it evenly distributes the light in all directions. Okay, so if you see these two lamps are semi-indirect lamps. Semi-indirect means only 40% to 10% will travel towards the surface, and remaining 60% to 90% will travel towards the ceiling. Okay, so just for clarity, let us consider it as 60%. 60% will travel towards the ceiling, and 40% will travel towards the surface. So these parallel dark lines represents the um, dark area, and this blank space represents the brighter area. Okay, so the last one is the indirect lamp. Indirect lamp means 100% illumination, 90 to 100% illumination will be provided on the ceiling. Only 10% or 0% illumination will be provided on the surface. So it doesn't mean that since 100% illumination provided on the ceiling, the surface will, it doesn't mean that the surface will be dark. Okay, so whatever illumination that is provided, that is directed towards the ceiling, the luminous flux lines will strike the ceiling. From there they will means they will incident on the ceiling, they will be reflected towards the wall. From the wall the light rays will travel towards the surface. Okay, so whenever we use indirect lighting, it doesn't mean that in order to make the surface darker and not to brighten the ceiling, we are not using this. Okay, it doesn't mean like that. Okay, so one more image. So direct lighting, indirect lighting, semi-direct lighting, semi-indirect lighting, diffused lighting. Okay, so direct lighting example, one more, semi-direct lighting, indirect lighting, semi-indirect lighting. This is okay. This is our diffused lighting. Okay, so one more image is there. I have inserted many images. Okay, so you can see the luminous flux lines. Okay, you can see the luminous flux lines here, 90 to 100% down light. This is our general diffuse lighting. Means general diffuse lighting, it should be 50-50%, 50% upward and 50% downward. Indirect lighting should be 90% upward or 100% upward. Semi-direct means 60% downward, 40% upward. This light, you can see the arrow marks which show the direction of the luminous flux lines. Okay, so this is about different types of lighting schemes. Okay, so next one is design of lighting scheme. Okay, so design of lighting scheme, let us discuss. So lighting scheme should be such that it may provide adequate illumination. Okay, it is well known. Okay, why we use lights? The purpose of lighting a room is to get adequate illumination. Okay, and whatever illumination that is provided by these lamps which we are using in a particular room, okay, that illumination should be properly or evenly distributed. Means the luminous flux line should be evenly distributed throughout the room, as well as especially if I am writing or reading for writing purpose or reading purpose, if I want proper illumination in a room, sufficient illumination should be there on the work plane. Okay, so and they should provide a suitable color. The light whatever I am using, it should provide me a suitable color. It should avoid glare and it should avoid the shadows. Okay, so if this all these conditions are fulfilled, then it is good lighting. Okay, so there are some factors that are to be considered while designing the light. Okay, there are some factors that are to be considered while designing the lighting scheme. Okay, so not while designing the lamp, while designing the lighting scheme. Okay, so those factors are illumination level. Okay, uniformity of illumination, color of light, shadows, glare, mounting height, spacing of the luminaries, and color of the surrounding walls. Okay, so illumination level is to be considered while designing a lighting scheme. Uniformity of the illumination in a particular room or the area. Color of the light is also important. Shadows are important. Glare is important. Mounting height, spacing of the luminaries means spacing between the lamps. Okay, coloring of the surrounding walls. What color that you are with what color you are painting the walls in which you want the illumination is important. So let us discuss these factors one by one. Okay, let us discuss these factors one by one. So illumination level. Okay, the first factor is the illumination level. So sufficient illumination in a room is very, very important. Okay, if sufficient illumination is there in a room, then only we can see our surroundings. Okay, okay, unless it is a light source. Okay, means if there is a light source in a room, a number of light sources are there. So the illumination due to one light source is not required for the illumination of another light source. Okay, because it itself can provide sufficient illumination in the room. Okay, so the main role of the illuminating object is to distribute the light evenly throughout the room, so that we get distributed brightness in the room. Okay, so each body, each object in a particular room. Okay, so there will be n number of objects in a room. Okay, so rooms will not be empty. Okay, in our houses also, the rooms will not be empty. Okay, so there will be different objects in each and every room. Okay, and each object, depending on its color, its texture, okay, it will have a property of reflecting light at different degrees. Okay, so it is this differential brightness which gives essential perception of details. Okay, so depending on the body color, okay, of the object on which the light is falling. Okay, so so now each type of work for each type of work there will be a range of brightness most favorable to the output. Okay, so it depends on what type of work you want the lighting. Okay, so what should be the range of the, of course, the rating of the lamp that you are going to use will vary depending on the work plane or workplace on which you want to fix the lamp. Okay, so the brightness will be, the range of the brightness will be most favorable to the output depending on the type of the work. Okay, so it should cause, what the lamp should cause minimum fatigue, and it should give maximum output. Okay, in terms of quality and quantity. Okay, so whatever type of lighting that you are going to use in a particular room, okay, it should give minimum fatigue and maximum output. Okay, so the degree of illumination to give necessary brightness to the objects depends on some factors. Okay, so one of the factor is size of the object to be seen and its distance from the observer. Okay, so how bright the object will look when it is illuminated by a lamp. Okay, it depends on what is the size of the object and how far it is from the observer. Okay, so now why do we illuminate the room? Because we want to reduce the fatigue to our eyes, isn't it? So we want everything to be clearly visible to our eyes. So for human comfort, we are illuminating the room. Okay, so if the object is at a greater distance from the observer, it will look smaller. We already know that. Okay, far away objects will look smaller and nearby objects will look larger in size. Okay, so if I want to see a faraway object, I require more illumination, isn't it? I require more illumination to see the faraway objects. Just for example, if you see in this image, okay, where is the image? Sam have gone far away. So if you see in this image, there is an Eiffel Tower here. Okay, so when I'm looking at it from a very long distance, it seems very small. Okay, if I go nearby to it, if I go and stand nearby to it, I can't even clearly see the whole Eiffel Tower from nearby. I can see only parts of it. I can only see the bottom part of that Eiffel Tower. That's all. Okay, so I can't see the whole image of that Eiffel Tower. Okay, so if proper illumination is not there, if I'm looking at a faraway object, then I can't recognize it clearly. Okay, I can't identify it clearly. Okay. So that's it. Okay, so degree of illumination to give necessary brightness to the object, it depends on one of the factor, that is size of the object to be seen and its distance, okay, from the observer. One more thing, one more factor that is to be considered to get proper brightness of the object depending on the degree of illumination. Okay, for you people it has already changed, for me it won't change at all. One more factor is that the contrast between the object and the background. Okay, so if you see in this image, if you observe carefully, how the wall color is matching with the balloon. Okay, the wall color is matching with these balloons. So the wall color is actually it's not blue color. Okay, there is a name for it. I am unable to recall it. Okay, so just for example, if you see the wall color is similar to these balloons. Okay, so there is no contrast between this balloon and this wall. Okay, so proper illumination is not provided here. Okay, so then I can't identify the, I can't recognize the I can't recognize the balloons with respect to the wall. So they will seem as if proper illumination is not there. They will seem as if there are no balloons at all. Okay. So if you see there is a red balloon here. Okay. So which is exactly in contrast with the color of the wall. Okay. So when there is proper contrast between this red balloon and the wall, the illumination required to identify this balloon is less. Okay, so whenever there is a proper contrast between the object and the background, then the illumination required will be less. When there is no proper contrast between the object which is to be illuminated and the background, then the illumination required will be more. Okay, so two factors are to be considered here. One is, okay, the degree of illumination will depend on two factors. Okay, one is size of the object and one is another and distance at which the object is there from the observer. Other one is contrast of the object with respect to the contrast of the object with respect to the background, and one actually one thing that we can we people already know that if the if we are seeing an means if I am looking at an object for longer duration of time, then I need more illumination. Okay, so more illumination is required whenever we look at an object for longer duration of time. One more thing is, whenever we are looking at a moving object when compared to stationary object, more illumination is required. Okay, so more illumination is required for looking at a moving object and compared to stationary object. Okay, so if you see a train is moving here, okay, so if proper illumination is not there, I can't identify the compartments of this train. Of course, I can only see the lamps which are glowing in front of this train. Okay, so as the distance varies with respect to the object, okay, as the contrast between the object and the background varies, okay, the degree of illumination required will also vary. Okay, so according to, so there are, these are the recommended levels of illumination for different aspects. Okay, like proofreading. So whenever I want proofreading, I'll the illumination required. So, and whenever drawing, for drawing purpose, the illumination required is 55 to 95 lux. For reading purpose, we require 95 to 185 lux. In museums, 35 to 55 lux illumination is required. In bedrooms and waiting rooms, 8 to 32. In hospitals, 5 to 10. In hotels and restaurants, okay, at reception, dining room and bedroom, 50 to 200. At accounts and writing desk, 300 to 400. This is to just to give you some information, that's all this data is. Okay, so in power stations, okay, in power stations, boilers will be there, turbine stages, transformers, switchgear equipments will be there. So you need around 100 to 150. In control rooms, okay, so in canteens. So this is all, these are all the luminous ranges for based on the requirements. So this is the data. Okay, and so no. Okay, so as per ISI, the illumination level required, you already know what is ISI. So the illumination level required in various parts of a building. And if you consider a particular building, and in various parts of a building at the entrance, the hallways, it is around 100 lakhs. In the living room, 300 lakhs. In the dining room, 150 lakhs. So okay, you can go through this data later on. Okay, so there is nothing to explain in there. Okay, so the illumination required as per ISA for various traffic routes. Okay, so the traffic routes can be classified based on the illumination into Group A1, Group A2, Group B1, and Group B2. So the traffic, the illumination for Group A1, it is Group A. The road which comes under Group A1 is important traffic routes carrying faster traffic. Okay, the illumination required for such group is 30 lakhs. Okay, so if the roads which comes under group A2 is another main roads carrying mixed traffic like main city streets, arterial roads, throughways, etc. Throughways means people where people mostly move. Okay, people will be moving most of the time. Those ways are known as throughways. So group A2, it requires only 15 lakhs. If group B1, it is the secondary road with considerable traffic like principal local traffic routes and shopping streets, etc. They require only 8 lakhs. Group B2 is secondary roads with light traffic, that is, they require only 4 lakhs. Okay, so these ranges are to give you some information. That's the lux means illumination readings are to give you some information. That's all. So we will discuss this next topic. Okay. So, in the uniformity of illumination, we will discuss, and few more terms are there in the tomorrow class. Okay, I will take attendance now.